Now for the problem 2, we're going to find the indefinite integrals by using a change of variables. We'll firstly look at the first one. It is the integral of x times e to the x squared of dx. Okay, so for this one, we can use changed variable to let u to be x squared, which is just the power of the e here. And then du, if we differentiate u on the left-hand side and differentiate x on the right-hand side, we'll have du equal to 2x times dx. Okay, and then we're going to solve for dx, and this is equal to dx equal to du over 2x. Now plug everything into the original setting, integral of x times e to the x squared of dx, where we keep x and x times e to the x squared, but x squared is equal to u. We have u, e to the u, times dx, but dx now is equal to du over 2x. And then you can see this x in the numerator and this x in the denominator can be cancelled. What we have is actually the integral of 1/2 times e to the u of du. And then its antiderivative is obvious, and it is equal to 1/2 times e to the u. And then if you're looking for a indefinite integral, always remember you're going to add a constant. Okay, so the result will be 1/2 times e to the u plus c. But u is not in the original problem. We're going to replace u by x squared. So that is 1/2 times e to the x squared plus c. And this will be our final result. So two things to remember. Firstly, always remember to add a constant when you're looking for an indefinite integral. The second part is when you're doing a change of variable and you define a variable of u, and in your final result, please replace u, the variable you defined, by the original variable in the problem. In this setting, it is x. Okay, so this is the first part. And then for the second part, we're going to integrate 1 over 2x plus 5. And here we're going to let u equal to 2x plus 5. And then du is equal to 2 times dx. So basically we are differentiating this function here. On the left hand side we're differentiate with respect to u, and on the right hand side we're differentiate with respect to x, and we will have du equal to 2dx, and dx is equal to du over 2. Okay, now we are going to integrate the original function, and that is the integral of 1 over 2x plus 5, but 2x plus 5 is just u, times dx, and dx is equal to du over 2. So basically we are going to integrate 1/2 times 1 over u, and the antiderivative of 1 over u is the natural log of the absolute value of u. So we will have 1/2 times the natural log of absolute value of u plus a constant c. And in the very end, we're going to replace u by the original parameter we have in the problem, or the variable in the problem. That is 1/2 times natural log of u, 1/2 times natural log of 2x plus 5, and then plus a constant c. And this will be our final result. Alright, Now we're going to look at the third problem. Alright, firstly, before we actually doing this problem, we're going to do some other observation of this function. We can see that on the numerator it is just a constant 14, but in the denominator it is 1 plus 49 times x squared. And you know that 49 is 7 squared, so actually we can rewrite this as 1 plus 7x squared. Okay? And then, well, actually at this point you may feel, okay, it is something about 1 over the antiderivative of 1 over 1 plus x squared. Well, actually it is, but with a constant or a coefficient. So in this problem, we're going to let u equal to 7x, and then du is equal to 7 dx, and dx is equal to du divided by 7. And then we're going to look at this problem, that is integral of 14 over 1 plus 49 x squared dx equal to the integral of 14 over 1 plus 7x squared of dx, and this is equal to 14 over 1 plus u squared times dx is du over 7. Okay? And then we can do some cancellation of the numbers. We know that 14 and the 7 have common factor of 7, and the 14 divided by 7 is 2. And then we can put 2 in front of the integral. 2 times the integral of du over 1 plus u squared, and the antiderivative of 1 plus u squared is arctangent of u, so we have 2 times arctangent of u plus a constant of c. And then in the variant we're going to replace u by x, that is 7x, so we have 2 times arctangent 7x plus c, and this will be our final result. Alright, for the fourth problem, we're going to integrate x over x plus 1. In this case, we're going to let u equal to the denominator, that is x plus 1. And then from here, you will solve for x, that is x is equal to u minus 1. So we can replace the numerator x by u minus 1 and the denominator x plus 1 by just u. And then if we differentiate both sides, we will have du equal to dx. And now we're going to plug every piece into the original problem. That is the integral of x over x plus 1 dx equal to the integral of x, which is equal to u minus 1, and the denominator x plus 1 is just u. Then dx is equal to du, and replace dx by du. And then we can by using the algebra, we can rewrite this fraction function in the middle as 1 minus 1 over u of du. Okay? And then we're going to integrate this function here. So it is equal to the integral of 1 du minus the integral of 1 over u du. And the antiderivative of 1 is just u minus the antiderivative of 1 over u, that is natural log of absolute value of u. And then remember, plus a constant c. And finally, we're going to replace everything in terms of u back to x plus 1. So that is x plus 1 minus natural log of absolute value of u, that is x plus 1, plus a constant c. And this is our final result.